Hello everyone, today let's solve the problem number 135 candy, right? So let's see what the question states here. We must give each child at least one candy, right? So just give me a second, 1 second here. Yeah, we must give the child at least one candy. If a child has higher rating than the adjacent neighbor, they must get more candies than that particular neighbor, right? Again, if a child has higher rating than an adjacent neighbor, they must get more candies than that neighbor, right? So we have to return the minimum total candies that is required. In simple terms, we have what we need to return. We need to return the minimum total candies that is required, right? So let's come to the example one here. So we have ratings 102, right? So output that we got here is 5. So they have clearly mentioned in the explanation. See here, we can allocate to the first. Yeah, we can allocate to the first, second and the third child with 2 and 2, right? Candies respectively, basically, right? So we can allocate to the first, second and third, this one, first, second and third child with a 2 and 2 respectively, right? So we can here, right? So 2, 1 and 2 candies respectively, right? So here total will be 2 plus 1 plus 2, it will be 5 basically, right? So simple, right? So second one, they have given this one ratings 1 to 2. So here on this case, in the question what they have given, if the child has higher rating than the adjacent neighbor, they must get more candies than that neighbor, right? So see here, higher ratings, this one is having the higher neighbor, this one ratings, right? So we can just give the 2 here. So this one will consider with 0 and 2. So this one will be 1 basically, 1 itself, and this one will remain 2 itself, right? So 2, 1, 2, this will be 5. So second one we have 1, 2, 2. So we have the output 4 here. See here, we can allocate to the first, right? So we can allocate to the first, second and third child with, so this one remains same, 1, 2 we have. So this one will remain same, 1 itself, because 2 is greater than 1, right? So this remains 2, right? Again we'll go with the 2 and 2. So this time it will be, we can allocate 1 candy respectively, right? So this one will be 1 plus 2 plus 1, basically 1 plus 2 is nothing but 3, 3 plus 1 will be nothing but 4. So overall output we will get here, we have to return 4 in this case. So they have clearly mentioned here, the third child gets 1 candy because it satisfies the above 2 conditions, right? So this is fine. I hope this part is completely clear, man. They have given us wonderful examples here just for the sake of understanding. Now let's move on with the approach part, right? So first thing I want to mention here is we will be going with a greedy approach, right? So this will be last problem we'll be solving on the greedy approach, right? So next we'll be moving on with intervals basically. So now this will be the last problems on the greedy basically, right? So we will be, first step here, we would be initializing every child with 1 candy, right? So every child is greater than or equal to 1, so we will initialize every child with 1. We have considered this first example, we have 1 0 1 0 2. So we will be initializing this one, every child with 1 candy basically. This will be 1 1 1, right? So next one will be, going with the left to right pass. We'll be going with the 1 pass, right? As we are making use of the greedy, we'll be going with the 1 pass. So we'll be going with the left to right pass if the ratings of I is greater than ratings of I minus 1. I minus 1 in the sense next one, previous one basically, right? So if the ratings of I, this one, current one, is greater than the previous one, then we can just give candies of I equals candies of I minus 1 plus 1, right? So then we can increment, or just we can increment by plus 1, right? So if I equals 1, meaning 0 greater than 1, then we have to display no. So if I equals 1, then we can display then we can check 0 greater than 1, else we can just go with no, right? So same we can go with I equals 2 as well. See here, I'm just telling this one. So we'll be going with a left to right pass. If ratings of I greater than ratings of I minus 1, then candies of I equals candies of I minus 1 plus 1. We can just go with the incrementing by 1 basically, right? So this one, just remember these two things. If I equals 1, then we can just go with 0 greater than 1. If true, then we can display no, right? So this one, Same goes with I equals 2 as well. I equals to this one, we will be going with 2 greater than 0, else if it is true then we will be going with s, right? So this is fine, man. So basically here for I equals to 2, so this no, as we have got no, this remains same 1 1 1, right? So this we have got s, so this would be 1 1 2. Basically we'll increment this one by last one by 2. Basically this is fine. Plus 1 will be incrementing by plus 1, basically it becomes 2, right? So now we will be going with a right to left pass, meaning if ratings of I greater than ratings of I plus 1 instead of I minus 1, if ratings of I greater than ratings of I plus 1, then candies of I will be max of candies of I comma candies of I plus 1 whole plus 1, right? So we will keep the larger value to satisfy both sides this time, right? So now we will consider I for I equals 1 and I equals 0. For the I equals 1, so we will be going with 0 greater than 2, right? So if it is true then we will be displaying no here. So in this case it is no, so we will keep this one as it is 1 1 2 previous value, right? So this is fine. Next we will be going with I equals 2, I equals 0, sorry, I equals 0. So this one if false we will be going with this one, I 1 greater than 0 will check. So if it is true then we will go with s, right? So here in this case candies of 0 will be as I have said, this will be max of candies of I comma candies of I plus 1 whole plus 1, right? So this will be max of 1 comma 1 plus 1, right? So this will be max of 1 comma 1 plus 1. Max of 1 and 2 will be basically 2, right? So this one we can represent on this format, right? So first one we will increment by 2, second one and third one remains same 1 and 2, right? So this becomes 2 1 2. So now what we will do, we got 2 1 2, right? So we will sum up all the candies. So we got 2 1 2, we will sum up all the candies here. So this one will be 2 plus 1 plus 2 basically, right? So this will lead to the this one output 5. This will lead to output 5, right? So this is nothing but 2 pass greedy, right? So this is minimal because we only increase where strictly required by the neighbors, right? So this is nothing but the again this is nothing but 2 pass greedy, and it is minimal because we only increase where strictly required by the neighbor. So total output that we got here is 5 when we sum up all the candies, which is equivalent to the output that they have mentioned for the example 1 within the question, right? So our approach works absolutely correct on this case. As we are completely familiar with the approach, let's do one thing, let's quickly discuss the complexities. So what will be the time complexity here? So the time complexity would be big of n, right? So the time complexity would be big of n because we will be making use of, or accordingly with the approach we went with the 2 linear passes over the ratings array, right? So overall time complexity would lead to big of n. So what would be the space complexity here? Space complexity would be big of n as well, because we will be making use of an this one auxiliary candies array of size n, right? So just remember this one. So space complexity would lead to big of n as well. So the time complexity and the space complexity for the code that we will be writing in the future would be big of n and big of n respectively, right? So let me delete this one. So now yep, let's do one thing. We are done with the this one candy approach. We are done with the approach and the complexities, sorry. So now as we are completely familiar with the approach and the complexities, let's start writing the code. First thing is, if input is null we have to return 0, right? So here I can just write it on this way. So this one ratings, if it is if it is null, then let's return 0. This is fine. Now let's go with number of children. So we'll be making use of the ratings dot length, this one. So I'll just assign that one to the some variable, right? So let me assign this one to the variable n. So I'll just go with ratings dot length. So this is fine, man. Next step is, if no children, then also we have to return 0, nothing but the defensive part. So I can just write it on this way. If n equals 0, then we have to return 0, right? So this is also fine. Next thing is, let's go with a candies array that holds assigned candies for each child. So we need to start with all this one once, right? So I can just write it in this way, int candies here. This one, let me assign this one to the new int of n. This is fine. Now let's move on with the iteration part here. This one will be int I equals 0, I less than n, I plus plus. So this is also fine. So within the for loop, let me assign candies of I. So this one to the 1 basically. This is fine. So every child must have at least one candy, right? So I'll just come out of this one entirely. So let's move on with the left to right greedy pass, right? So we went with two linear pass, right? Left to right greedy pass as well as the right to left greedy pass. First, let's go with the left to right greedy pass. So if the current rating is greater than the left rating, accordingly with the approach, if the current rating is greater than left rating, then we have to give the current one more than the left child, right? So let's go with the iteration here. This one int I equals 1, I less than n, I plus plus. So within the for loop, I'll just write here what's the condition. If ratings of I, if it is greater than ratings of I minus 1, this is fine. So within the if condition, so this one will be candies of I. Let's assign this one to the candies of I minus 1 plus 1. So this is fine, right? We are just increasing to satisfy the left neighbor constraint. So now let me come out of this one entirely. Now let's move on with the right to left pass. Also we have to go with the sum accumulation as well, right? So we'll be going with right to left pass along with the sum accumulation. So this one will be int sum equals 0. Let's move on with the iteration part. So this one will be int I equals n minus 1, I greater than or equal to 0. So this will be I minus minus. So within the for loop, let's go with a simple if condition here. If I less than n minus 1 and this one ratings of I, so this one greater than ratings of I plus 1. So this is fine. We have to take the max to preserve any previously assigned value from the left pass. So this one will be candies of I equivalent. So this one will be math.max of candies of I, this is fine, comma candies of I plus 1 totally plus 1. This is fine. Now let's do one thing. Let's go with this one. We have to add the final candies of I to the total, right? So here sum equals sum plus candies of I. So finally we are left with only one thing. Here we have to return the minimum total candies satisfying both neighbor constraints, right? So in simple terms we have to return the sum. So I'll just return sum here. So let me format the code once and let me hit the run button. I hope this works, man. Let's see. So here you can clearly see the sample test cases are getting passed. So let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed, meaning our code works absolutely correct here in this case, right? So whatever the code that we have written works absolutely correct for all the test cases. So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.